All right, so the last two examples, we looked at how to graph a quadratic equation, and all we did was just make a table, and we plugged in x values, and we got y values. Both of those examples did not have a b term, if you noticed. We just had an x squared term, and we might have had a c term in examples 1 and 2. Now what we're going to do is add in a b term here. But before that, we want to talk about and just explore what are the properties of ax squared plus bx plus c. So what I'm going to do is go to Desmos, and I just want to figure out what do these three parameters actually do here. So, what does the a do in terms of my graph? What does the b do? What does the c do? So we're going to explore that real quick. If I have y equals x squared, and feel free to either just kind of watch or just go on your computer and just try this out and explore, because the more that you do, the more that you're going to remember and learn. If I just have y equals x squared, there's my parent function. And if I change the a value here, let's say I say y equals 2x squared. 2x squared. You can kind of see what it does. It makes it skinnier. If I make that a negative 2, now it opens down. And if I make that just a general ax squared, right, we can add this to our Desmos, and then we can play this parameter. If a changes, what happens to the graph? Well, as a gets further away from 0, you can see the graph getting really, really skinny, right? If a is negative, it opens down, right? And if a gets further and further away from 0 in the negative direction, it just also gets more and more skinny, more and more narrow, but in the negative direction. So the a value is basically going to have that type of effect on your parabola. Now, let's think about what does a c value do? We did that in example 2. If I just say, hey, let's take a plus 2 here, right? What just happened to the graph? Let me reset this back to 1. If I say plus 2, notice that the graph just moved up 2, just translated up 2. If I say, if I subtracted 2, well, then it just took the same shape and went down 2. So the c value here, if I just put, in general terms, plus a c value, and I added a slider there, and I change the c value around, notice that from the red graph, which is the basic parent function, if I move this c value to negative and positive, it's the same graph, it's just moving up and down. That's all it's doing. Very similar to the absolute value ones that we saw in chapter 1. So there's the c value. Okay. Now the next question is, what does the b value do? So we haven't looked at that at all yet. So if I add in a plus bx, I'm going to add a plus bx in there, and I'm going to add a slider to that. Okay, so what if I change the b value around a bit? And I'm just going to play this and see what the graph is doing here. So you can see, all right, well, one thing you can see is that the y-intercept doesn't change. Also, the graph is always opening up, right? Just as the red graph is, the parent function to the new graph is always opening up. What's changing here? Well, you can see the axis of symmetry is changing, right? The vertex, right, is changing. Those two things are definitely changing in this graph. And so I just want you to notice that. The b value changes the vertex, where the vertex is located, and it changes where the axis of symmetry is. And so if we were to put down some of these summaries here, the graph is always going to open up if a is positive or a is greater than 0. And the graph is going to open down if a is less than 0 or negative. And then we talked about as a gets further and further away from 0, or in other words, as the absolute value of a gets bigger, the graph gets, I'll say, more narrow. And as a gets closer to 0, or as the absolute value gets smaller, the graph gets more, I'll say, wide. It kind of widens out there. Now, one thing that is not going to be obvious for us in Algebra 2 yet is the axis of symmetry. The axis of symmetry, or the middle line, you're going to have to remember this or write this down, is always going to be x equals, and it's going to be negative b over 2a. Remember that the b value that we were just talking about was changing around the axis of symmetry and also the vertex. So it makes sense that the b value is in this little equation. But this is something that you're going to use a lot in this whole chapter, especially in the graphing. So make sure you remember that and write that down and bubble it in. So the axis of symmetry is negative b over 2a. Also, the vertex has an x coordinate of the same thing, right? Because it's the middle of the graph. So if I went back to my Desmos, and I just wrote this in, if I said x equals negative b divided by 2a, notice what happens here. That line that I just did, or just graphed, notice that it's staying exactly in the middle or the center of the graph that's changing. It's locked in to that axis of symmetry, and it's right in the middle. Right? If I stop this, let's stop it right here. Okay, so negative b over 2a right now, which again the numbers, I'm not sure, you could look at all these numbers. The a value right now is 1, the b value is 2.67, and the c value is 0.2. But if we were to calculate negative b over 2a, which is negative 1 point, whatever, that's right here. Okay, that is the middle of this graph that we're currently plotting. And notice that if I click on the vertex, it's also the x value of the vertex. So this negative b over 2a that we calculate is an important piece of the vertex right here. And it also tells us exactly where on this x-axis is the center line, the axis of symmetry. All right, and so so this is a huge part of what we're going to be using. And then the y-intercept, if you didn't notice that, is the c value always, right? The c value, just like mx plus b in terms of a linear equation, the b value is the y-intercept. And the same thing happens here, that constant value at the end happens to be the y-intercept, because if I plug in 0, both of these terms are clearly going to go away, and my c value is going to be what's left over. So 0c is on the parabola. So make sure you write some of these things down, especially this one right here. These are the patterns or some of the shortcuts we can take as we proceed in graphing our parabolas.